Hello, everyone. I'm here to talk about vulnerability management, when it comes to vulnerability management, prioritization, and augmenting the vulnerabilities with additional information such as, uh, you know, CISA KVs, EPSS, and all the other uh, external factors is extremely important. Today, I'm going to show you how AccuKnox helps you prioritize the vulnerabilities that are discovered as part of container images or even on the virtual machine itself. Uh, this feature is called as verified feature. So the aim here is to show users the vulnerabilities that are impacted in the runtime. So typically, when a vulnerability is identified, that vulnerability is identified in the context of a package, and that package may or may not be used in runtime. If it is not ever used in runtime, then the risk is real low. So why bother fixing that? You can focus, or you can have your security team's bandwidth focus on tickets that or issues that might be impacting in the runtime itself. This information it could be found on help.accunox.com. uh, the aim here is that within the runtime environment, AccuKnox has visibility into the runtime environment as well as it has visibility into all the container image scan. So AccuKnox supports two types of container image scanning. One is the scanning through container registry or CI/CD pipelines and all of that stuff, as well as it supports image scanning within the Kubernetes clusters itself or as part of virtual machines itself. So if you are directly using Docker or Containerd directly on the virtual machine, AccuKnox can scan the container images directly on the virtual machine itself. The scan reports are sent to AccuKnox control plane. Similarly, if we are using container registry, the image registry is scanned, and then we have the information. Uh, and on the other side, AccuKnox has a runtime security engine called as KubeArmor, which has the ability to send telemetry, such as process invocation, file access, network access, telemetry to AccuKnox control plane. The prioritization logic in AccuKnox does following. It combines the CV information, it uses the package information, it leverages the runtime telemetry and says these are the packages or these are the vulnerabilities in these packages which we have seen executing in the actual runtime environment. One more thing I would like to point out, shipping this telemetry from the Kubernetes clusters or virtual machine is easier said than done. Uh, Achieving this at scale is a big deal, is a real big problem. And AccuKnox has patents in the context. One of the patent is to do optimized in-kernel aggregation of runtime telemetry. The information is present here. This was granted to AccuKnox a couple of years back. You'll see this information. This was granted to AccuKnox last year. AccuKnox has filed for this in 2020. And we are really proud of this particular work because this allows us to scale with no impact or very least impact. I won't say no impact, with very least impact on the workloads itself. Now, enough said. Let me go and show you what happens. So when you have a cluster, when you onboard a cluster, let me show you the onboarding instructions. So whenever you onboard a cluster, you can onboard the cluster with runtime visibility and protection. This basically installs KubeArmor and AccuKnox agents in the target cluster. Then you can also enable scan running images. So this ensures that the images that are actually active in the target Kubernetes clusters are the only ones which get scanned. You can do this on virtual machines as well as on Kubernetes. Once you do this, then you'll see the corresponding, when once the scans are complete, you'll see the corresponding vulnerability show up here. For example, in this case, I have this cluster self, which contains roughly 22,000 vulnerabilities. Now, these are too many vulnerabilities, right? Like 22,267. But now, across all of these vulnerabilities, you'll see that we have a runtime verified flag. Whether if it is true, let's see how many of these vulnerabilities, uh, how many of the packages associated with these vulnerabilities are actually seen in the in the runtime environment. So you see, from 22,000 vulnerabilities, it dropped down to 1,510 vulnerabilities. So that's the impact here, right? Like it reduces the number of vulnerabilities by 100x in this case. Now let me open up one of the vulnerability and show you what information. So here you can see this is the vulnerability detected in OpenSSL, OpenSSL-libs package. And this package, it's mentioned as to this, there are runtime libraries. This is the runtime library that AccuKnox has seen executing 7 days back. This is one of the library and this is another. So libcrypto and libssl, which both of these are part of OpenSSL libs package, and they are seen in execution in the runtime on those particular days. Now, what I'll do is I'll show you the application behavior. You can verify this, and AccuKnox supports something called as application behavior visibility. Now here, it has file observability, process network observability. You can apply a filter saying file path accessed. I'll just put up regular expression. I'll put libcrypto and see how many of my packages are actually using it. So since this is in last 2 days, if I increase it to last 2 weeks, so by default, AccuKnox searches for the last 2 weeks. So you see these are the different packages, workloads that are making use of this particular library, and libcrypto is definitely in use. So you can verify that those aspects from here itself. Let me go back to the corresponding findings again. So we looked at OpenSSL. Similarly, so it need not necessarily be a runtime library, but it could be runtime processes as well. For example, here we have a Golang vulnerability where Golang is a single library, a single binary that is created. So this binary /bin vault has been seen execution in the runtime environment 7 days ago, and this contains this particular CV, and we see that this impact is present at runtime. So this becomes an important vulnerability to be fixed because the severity is high, uh, and it's important that we fix it. And more importantly, this is identified in the runtime process information. There's one more aspect. So the same thing can be done on virtual machines as well. So when vulnerabilities are found out on virtual machines, so AccuKnox has the ability to scan not just the container images, but the packages that are present on the virtual machines and get the same kind of information. For example, let me just uh, set this. So currently on this virtual machine, we have 906 vulnerabilities. And when I click runtime vulnerabilities, so you see almost half of the vulnerabilities were gone. And you'll see this. So you'll see here the this is the asset name, Murtaza runtime world. This is the name of the virtual machine, and this virtual machine has this particular CV. This CV is within this particular package, and this package was seen executing 5 days back and 6 days back as well. So this particular file was accessed 6 days back. So these files are part of this particular packages. Another question that gets asked to us is that is it only the packages that are installed through package managers which will be detected? That's not the case. Even if you are manually creating the package, you are manually creating the application. So even if someone copies the Go binary or any other binary directly to the target virtual machine or within the Kubernetes pod itself or a container itself, will still be able to detect it, the vulnerability in the context, as well as whether it is present in the context of in the context of runtime environment. Another important thing to note is, these vulnerabilities, the vulnerabilities that are detected by AccuKnox uses external vulnerability sources to augment further information. For example, NVD is something that is NVD and CW is what almost everyone uses. AccuKnox also uses some other sources such as Microsoft Security Review Catalog, I think, MSRC. EPSS is another important scoring mechanism from first.org. NVIDIA, especially for the AI assets, CISA KEVs, known exploited vulnerabilities catalog. This tells you whether this given CEV was actually exploited or seen exploited in the real environment. And then there are something called as GitHub PoCs. So GitHub PoCs gives you an actual PoC to exploit that particular vulnerability. So if there is a GitHub PoC, there is most likely that there is a chance that it will be part of CISA known exploited vulnerability as well, and that makes the finding very critical. All of this could be used for prioritization perspective. This is extremely important because no one wants simple dump of the vulnerabilities itself. Security team wants to prioritize because they have limited bandwidth, they have less manpower, and within using that manpower, they want to fix, work on the vulnerabilities that are most important to be fixed. So this AccuKnox, both the runtime visibility, runtime reachability, as well as augmentation of external sources helps you achieve that. Thank you.